I'm going to just kick us off with a little bit of an explanation of where we are. Most of us have technical debt, so we'll discuss what that is and what we can do about it. I'll move into the benefits of modernizing, of addressing debt and how AWS can support that initiative, and then some of the principles and strategies for modernizing, and I'll wrap with a case study of an organization we helped through this process. So a little bit before I get there, about me and about who Logicworks is. Logicworks is a leading cloud services provider that can help get you to the cloud, support you once you're there, and optimize you for future growth, whether that's app modernization like we're talking about today, from enterprise to open source software, or just overall improvements of efficiency and cost optimization. So our specialties are security and mission critical infrastructure, as you can see through some of our reference clients. All these are 24/7 platforms that have a high compliance mandate. You can see some of the compliance that we personally are audited for on the lower left. Outside my role at Logicworks, much of my life is focused on community service. I'm a Marine Corps veteran, and I serve on the board of a local community development nonprofit in my city here. And then when I'm taking time to relax, I'm an amateur barbecue pitmaster, and if I'm not at home, you can find me on the hiking trails out around New York and New Jersey, and a little bit of Pennsylvania too. This is a photo I took just 6 weeks ago, I suppose, up in the Adirondacks in New York. It's a great place, highly recommend it. All right. So as we begin the conversation on technical debt, I want to dig into what that means, because for a lot of us, that's not a neutral term. It can raise our defenses, and certainly when directed at our products or platforms, it can be offensive. So I want us to level set on what I mean by this so we can all engage. We see the definition on the top of this slide, but I want to offer another plain English definition, and that's making do with what we have. Again, making do with what we have. And that can come in a lot of different flavors. That can be driven by a lot of different things. Sometimes we see this by deadlines in delivery and release cycles. There's a specific deadline that must be met, and sometimes that forces us to adopt code that hasn't been, it isn't quite up to snuff what we would want to put out there, but again, that deadline had to be met. Similarly, sometimes that deadline is looming and the code's not going to be ready, so we have to insert a third-party code or product at the last minute, and it works. It gets us to the release, but it's not necessarily what we would have wanted. So this is around dependencies. I personally see this with application and database versions, and oftentimes with scalability matters as well. Traditional applications not scaling well horizontally, or unable to leverage things, database read replicas, whatever the case can be, oftentimes results in these behemoth database or application VMs or instances. Related to this first point is over-engineering. I think, again, oftentimes driven by release commitments, often usually here with features, that a specific feature has been promised. And as I mentioned, open source or enterprise software that sometimes has to be plugged in. Well, sometimes you want to use. Someone's already doing a great job with that feature, but the specific feature that has been promised for the release, isn't included. That off-the-shelf package gets you 90% of the way there, but not rest. And so you have to go back and reinvent the whole, so to speak. And finally, the last one, just disparate teams manage things differently. And as staff naturally transitions, this can leave organizations with complicated support requirements. So, big picture, while having technical debt is a common thing, its impact on business is serious. So, in this illustration we see on the left side, we'll see that technical debt grows with time. It compounds, it continues to accrue. And what we see is it shifts organizations' focus from innovation, the blue bars on the top, to maintenance of existing resources, kind of the red on the bottom. And so I think this is something that we certainly don't want as organizations. I think if you've ever heard the line or the excuse, someone who's not here anymore built this, you are definitely facing technical debt. Those resources, the sentiment behind that statement usually is something that's burdensome, something that people usually know is not best practices, but either the skill, the time, or the technology to address them is unavailable. Bottom line, it prevents you from releasing new features, addressing new markets, or other endeavors that can build your business. So, why is it a concern? If that last slide didn't provide enough evidence, we see that technical debt also, just has a whole host of challenges on the operation side. The three biggest risks that I see personally when I work with clients are that environments with technical debt are not resilient, they don't scale well, and are inefficient in resource utilizations. This issue impacts your bottom line. It overburdens your team, and it can lead to lower job satisfaction, burnout, and attrition, which then just continue to increases the debt. So I think this paints a little bit of a bleak picture, but I think there's a lot of ways that we can address this. So one way that we can address technical debt is by adopting a modern microservice-based architecture. This might seem like a lot in the beginning, but as we will see, AWS has a host of services to help get you there. And once you get there, it ticks off all the boxes of what AWS considers their well-architected framework. It's the published recommendations for best practices in cloud operations. Finally, it provides you with a flexible, solid foundation to be able to grow your team and grow your application. I'm going to come back to this point a couple times, but it takes a little bit of investment up front, but it allows you to grow and operate at scales and allows you to pivot and build your business to your market demand. I mentioned that AWS has tools that can help support you in this process. Really, all the cloud platforms do nowadays. And so I'm going to focus here on AWS, but I'm sure this could apply on pretty much any platform. What does this look like here in AWS? Well, as you transition to a microservices architecture, the cloud has nearly every tool you could want to help you run these microservice applications. Compute services that can run applications in a serverless way, so you don't have to maintain servers anymore, patching, manage security settings, security tooling, all that stuff. It offloads some of that operational burden. Manage database and CI/CD tools. All these provide a benefit to you, so you can focus on building your application instead of just simple maintenance. You can now spend that extra time that you used to do on just the day-to-day drudgery to retire that old technical debt to build new standards-based modular components that you can iterate upon and fuel your continued development and growth. I mentioned the well-architected framework a couple slides ago, and as you get building, AWS has published guidance on how to build modern applications that considers the various stakeholders and requirements of the business and how to manage those interdependencies and trade-offs in an optimal way. AWS calls these domains pillars, and they all influence and impact each other. Operations deeply affect security, vice versa. Reliability and performance have a trade-off with cost, so we want to build things in a robust and resilient fashion, but we also need to be efficient as we do so to maintain our budgets. So as you get building with AWS, we recommend you follow the principles of these pillars. My favorite part of this framework is it isn't a binary framework. It isn't, are you doing well or not? What this framework does is it identifies risks so you can proceed in an informed way. I mentioned how operations and security oftentimes have trade-offs. In order to be, as locked down as your compliance mandate need, sometimes that takes a little bit of operational speed. And so that's a trade-off that has to be taken. There's risks there. On a trade-off that has to be taken. Now we're able to, once you identify that, you're going to be able to proceed in an informed way and make the best decisions for your business. These well-architected pillars also correspond to the fundamental pillars or principles, of a modernized architecture. So you see, the goal of a modernized architecture is to provide a flexible foundation to iterate upon, so you can develop new features, adjust your business model, whatever makes you money. And the focus here is for your staff to transition from maintaining infrastructure, because that's not what you make money on, but to focus on your app that does. Taking this a step further, you can deploy your application through CI/CD pipelines. So not only does your development speed increase, but your security does as well, because we're operating in an automated fashion that you can easily test, and it's readily auditable. Related, the microservices architecture is modular, so you can focus and iterate upon just a single aspect of your application, or create a new one from scratch, while not affecting the rest of your application. In other words, you don't have to worry that a change on your web service is going to affect the performance of an external API because these are separate. You're not having to worry about performance throttling in between. They're decoupled, and components can scale independently, allowing you to be very efficient with the resource you use. Teasing the efficiency out a little bit, with our old monolithic or even virtual appliance-based architectures. Before I was an AWS solutions architect, I was a VMware solutions architect, so lots of virtual appliances out there. This delivery method, that architecture, we had to size for peak capacity. The resources didn't typically scale horizontally or dynamically, so we had to waste a lot of resources by sizing for worst case scenario. And sometimes we'd scale up or down during a maintenance window because we knew traffic patterns. But again, that's during a maintenance window, which is never optimal. AWS, the cloud in general, can handle these for us through either auto-scaled compute, or many services are now even being offered in a serverless fashion where the platform is able to monitor and detect changes in mode and adjust resources in a just-in-time fashion. And this is very efficient as well as reliant, because again, you're taking care to removing all of those issues that could be caused by performance bottlenecks. Finally, reliability is affected by several factors we've talked about, the decoupling of services and also automation of operations. We talked about decoupling, how it can improve resiliency, but when we automate processes, we're also taking out a lot of the human error. Automation changes can easily be audited by change management boards. They can be logged and tracked easily for compliance purposes. It provides a much more robust and resilient system. We already talked about decoupling, so I won't discuss that by itself, but from an overall perspective, specifically from an operations perspective, and I came from the operations side of technology, so this is something I'm passionate about. These AWS services and this type of architecture empowers your team to focus on unique and differentiated work. So especially at those tier 1, tier 2 kind of positions, we're not just pushing buttons or watching status boards anymore. It's much more rewarding, a rewarding model for the employees themselves, but it's also much more rewarding for the employer, as you're more easily able to meet your business demands with all the flexibility that this provides. There's going to be a couple of standard architectures we see in modernized applications. The first is a template-based model with immutable infrastructure. This immutable infrastructure cannot be changed, so if an error occurs, we know that there must have been a system error that can simply be addressed by redeploying the infrastructure. This is very efficient for testing, as we can test rapidly at different stages of development, and everything is managed via code, so deployments are simple and fast. Taking it a step further, containerization can leverage all these strategies of immutable infrastructure, but in even more efficient and modular fashion. Uniquely, containers have successfully been used to refactor many old monolithic applications, as you can build a container with custom runtimes that might not be supported by either modern operating systems or just the system of your choice, potentially. You can deploy containers on AWS to EC2 clusters you manage independently, or you can manage what AWS calls Fargate, which is a serverless container hosting platform where you don't have to manage any of the underlying compute. Finally, going all in on the serverless approach, you could refactor to an event-driven architecture where serverless functions, AWS calls them Lambda, wait for input and they spool up instantly to serve the content or perform the action upon a trigger, and then it spins down afterwards. So, of course, this is exceptionally efficient, but conceptually, it can be a little bit of a leap for many people. I think when we get right down into the code, it's not that significant of a leap, but just the concept, the theory of how these systems work, it's a big leap, and so that can be a little bit challenging. I mentioned serverless options exist for containers where you no longer have to operate the underlying compute, but similar AWS services exist for nearly every other aspect of modern applications, from APIs to databases to storage. So I want to wrap with a case study. And we want to talk about how we help ServPro modernize their application. Some of you might know their name. They're one of those companies that if you've personally worked with them, I'm a little bit sorry. They're a fire and water disaster cleanup company. So they're great at what they do, and they're very nice. So, you certainly chose the best in a difficult circumstance. But it's certainly, if you've worked with them, it's trying times. So anyway, ServPro came to us wanting to migrate to AWS, but they had a massive monolithic application upon which all their other applications had a dependency. So while most of their applications would be a fairly straightforward migration to the cloud and were kind of cloud ready, this final monolithic application didn't have a compatible system upon which it could run in the cloud. And again, since all the application had a dependency upon it, nothing could migrate. It was either that one monolith can move or nothing can move. So what did we do? We built a modern containerized solution. In this case, it was based off of AWS's managed Kubernetes service, EKS, with an open source backend database. This solution preserved many of those custom runtimes that otherwise wouldn't be compatible. We oftentimes see this with monoliths. And it was modular and decoupled, so ServPro could now scale and develop components individually. It was both cheap to run from a cloud usage perspective and from an ongoing IT operations perspective. So finally, to support the remaining 200 application migration, we developed an automated immutable infrastructure pipeline that deployed all the infrastructure as code. And when we did the migration, it simultaneously deployed and cut over all 200 applications at once. It was truly an amazing thing to see. In addition, these infrastructure pipelines can continue to be leveraged for the ongoing operation and iteration of the platform in a secure, scalable, and rapid fashion. Talked about differentiating, the differentiating workload. Can focus on their application now, not just trying to support this one outdated system, and move into projects that continue to make them money. So there's definitely going to be a lot more today, but if you are interested in modernizing your application or talking with me about anything I've discussed, please feel free to reach out. I'm at cjohnson@logicworks.com.